Sir, please start. Hello.
Yes, yes. So screen visible?
Yes, sir.
Okay, so when to start?
Yes, sir, you can start now.
Okay, so everybody, first of all, I would like to thank Department of Civil Engineering, Parur University, as well as the authorities who have arranged this webinar, and particularly Parur Bansal, so for giving me this opportunity and inviting me to conduct this webinar. So my topic will be, you can easily see the title. Title itself indicates that we are more concerned about the environment. So that means construction, which is disturbing the environment or depleting the natural resources. So we want to address those concerns. So title will be the geopolymer concrete with industrial waste, that means use of industrial waste as well as recycled material for environmental friendly construction. So am I audible clearly? So should I continue? So just confirm me whether everything is okay and audible. Parul? Am I audible? Are we connected? So somebody should respond me so that I. Hello, someone should clarify that whether I'm audible or not.
You are audible, sir.
Okay, so everything is okay, so I can continue the presentation.
Yes, yes, sir, yes, sir.
Okay, so regarding the presentation, the outline of the presentation, first of all, I will be going to discuss regarding the construction material, then geopolymer based construction material, and then geopolymer concrete methodology and testing, and what type of research is going on in geopolymer field of the geopolymer concrete, then some case study and field application. We will be talking about the geopolymer utilization in pavements, then buildings, as well as a repair material. So let us first of all discuss what is the concern of showing this presentation, why we are talking about this. So when we are talking about the construction material, so conventional construction material, we utilize cement, concrete, and cement mortar. And still we are using those material because this material, conventional material, has very merits, and you can say some fascinating type of properties, as well as when we are talking about the cost. So low cost material are available because we are utilizing the natural occurring material like aggregate, sand, etc. So overall cost of the material is low. Moreover, we can customize the mechanical properties as per our requirement, and we can also control the performance. And we are getting that these material perform better with the age. As the age is going on, with the growing age, you will find that they are giving good strength as well as durability property. Very easily you can apply that easy application because even unskilled laborers people can utilize when they are used in the construction. and easily obtainability because these are the natural occurring material. So now topic is, if the conventional construction material are having such advantages, such merits, then why we are discussing this? There are some issues, and we have mentioned them, alarming issues and concern. So first of all, why these concerns? Because we are seeing the population growth, so which is expected to be nearly 10 billion in 2057. From the right side graph, you can see the forecasting of the population, world population per year. That means with year how it is growing. So you can see the growth is state growth. That means it is continuously growing the population. So world population forecast. Now, why we are talking about the growing population? So why this is an alarming issue and concern for engineers and environmentalists? So first of all, with the growing population, we need infrastructure. So demand for infrastructure increases. And when we are talking about the infrastructure development, then very important aspect is the cement requirement is also growing. So with the growing population, which we have discussed that it may be up to 10 billion in 2057, demand of infrastructure development is increasing day by day. And with the increase in the demand of infrastructure development, we are facing the huge demand for cement as a binding material. Now, to manufacture this cement, and this global demand, which we estimate is nearly 4.216 billion metric ton in 2018. And from this graph, right side graph, cement demand in future. And you can easily analyze that with the every year, demand of cement requirement is increasing yearly. And what we are expecting that average demand, average growth of cement requirement every year is increasing 3 to 4%. And it is expected that in 2028, approximately, the cement market will cost nearly 450 billion US dollar. So from these points, it is very much clear that the cement requirement increasing, and with the growth of cement infrastructure, with the requirement of cement, and during cement manufacturing, energy requirement is very important factor, which is a major alarming issue. So nearly 9.4 into 10 raised to power joule per ton energy is consumed in this cement production process only. And approximately 200 kg of coal is required for 1 ton of cement production. And we know that the coal is depleting day by day, and you are unable to manufacture coal. It's a natural resource. So that means with the demand, with the increasing demand of cement, we are depleting the natural resources. That means power resources, coal. Now, cement manufacturing process. So everybody who is associated with the civil engineering, they know that basic raw material for the cement manufacturing are limestone, it may be clay, and fuel. So during the calcination process, lot of carbon dioxide is released, which is an alarming issue. And after calcination, we got clinker, and then clinker is grinded, and during grinding process, carbon dioxide is released. So huge quantity of carbon dioxide is released in the environment. And everybody know that this carbon dioxide is not environment friendly, rather it is an environmental disturbing factor, and it turns in the greenhouse gases. Now, CO2 release, nearly it is estimated 5 to 7% of total carbon dioxide, which is released in the atmosphere from various sources, and nearly 5 to 7% is contributed by the cement production, which is a huge quantity. 5 to 7% is not a lesser quantity. Now, considering this as a prominent region, one of the prominent region to accelerate global warming, and we are facing the major issue with the global warming, change of the season, unwanted rain, and somewhere you are finding that there is no rain at all, and somewhere you are finding floods. Even in you say in the desert area, even in Rajasthan, we are getting floods. And why we are getting floods? Because due to global warming, seasons are consistently changing. And based on this, whenever there Earth summit happen all across the world, so they are very serious and they put forward the concern about the emission of these greenhouse gases. That means we need to, as a researcher, as a environmentalist, we need to check this emission of greenhouse gases and how we can curtail, how we can reduce these gases so that environment can be controlled. And for this, cement industry is always of major concern, and they are always want to switch over from Portland cement to some alternate, greener alternate binders. So that means we have to curtail the production of Portland cement, and we have to replace the Portland cement with some other alternative materials which are environmental friendly. So this is the concern and this is the base for this presentation also. Now, when we are talking about the industrial as well as agriculture waste, so huge industry is growing day by day, as well as agriculture industry is also there, and they are consistently producing the waste. And growing industrialization, as we have mentioned, they will release waste byproducts such as fly ash, rice husk ash, and GGBFs. A few years back, fly ash was considered as a waste material, but nowadays we are not saying it is a waste material because it is getting consumed in various even cement manufacturing process as well as some other building material. Now it is costly. We have to pay for the fly ash. And when we are talking about these type of materials, so very important thing which we can say, or very interesting thing, is that these material, these waste material, maybe they are waste, but they are pozzolanic in nature. So if you have a pozzolanic material, you can activate it. You can activate its properties and it can be utilized. But very important issue with these waste material, if consistently you are producing huge amount of these material, so they need dumping. And dumping in ground, again, it is environmental threatening. So we are concerned about the utilization of these waste material instead of dumping it somewhere. And the pozzolanic nature, yes, this is an interesting thing and this is fascinating thing. And this pozzolanic nature give us scope or create the scope for use it in cement industry. So that's why even government has restricted and you can say encourage the use of fly ash in the manufacturing of the cement. Now from this slide, you can see various waste materials, some of the industrial waste materials, some of the agriculture waste material. At the top, you can see fly ash, which is very fine material. It has pozzolanic properties, but you can't dump it. Otherwise, it will not get consumed anywhere. It will not react with any other material unless it is activated. Second is granulated blast furnace slag. This is also waste material, which is produced from the steel industry. Then third one is rice husk, and we burn this rice husk, and the rice husk ash will be produced. This is agriculture waste basically. Now, metacholine is one type of clay, refined clay. We can't now cover it as a waste material, which is a manufactured type of material. That means it is produced from the clay. Mostly in China or other countries, they are using metacholine. Another important thing is the demolition waste, that crushed concrete aggregate. So when you demolish a structure, existing structure, for the development of new structure, etc. So that waste material, that concrete, is crushed into aggregate form. So we as a civil engineering faculty, as a civil engineering student, a researcher, our main concern is to utilize this material in one or other way. Now, when we are talking about the geopolymers, so what are the primary requirement for geopolymer based construction material? If you want to develop geopolymer based construction material, so any pozzolanic material can be utilized. But you have to take care that pozzolanic material must be rich source of silicon and alumina. So they must be having good quantity of silica and alumina as a composition, and that pozzolanic material you can utilize as a primary material for the development of geopolymer. And they can easily dissolve in alkaline solution. That means that pozzolanic material, it may be fly ash, it may be rice husk ash. You can just add some alkaline solution. Later on, we will discuss. So that alkaline solution will activate the silica and alumina present within that pozzolanic material. So pozzolanic material, you can say, are the source of geopolymer precursor. So they are the initiator, base material. Second one, we need alkaline solution. And alkaline solution may be taken from sodium hydroxide and sodium silicate or potassium hydroxide, etc. And they can be used as alkaline activator. They are of alkaline nature and they will activate the silica and alumina present in the pozzolanic material. Now, this process, this activation process is known as geopolymerization. So this geopolymerization reaction in comparison to CSH gel formation. You are well aware in the conventional cement-based concrete, when you add water in the cement and other constituents, then some reaction, that exothermic reaction will take place. That means heat will be released and there will be the formation of a CSH gel. And that CSH gel is having the properties of binding property. So that's why cement is used. So ultimately you have to develop, you have to produce CSH gel. And that process, conventional concrete, that process is exothermic, but the geopolymerization process is not exothermic at all. So that means if you use geopolymerase based material, wet curing is not required as it is required in cement based concrete. So no curing is required at all. But you can do the heat curing or steam curing to accelerate this process of geopolymerization. So geopolymer because this rate of geopolymerization will influence the setting properties of the geopolymer based material, geopolymer concrete or geopolymer mortar. So interesting part is no cement is required. So few years back, if you talk about maybe 15 to 20 years back, people were not able to digest this truth that cement, without cement you can develop, you can produce any concrete. But nowadays, I will be later on show you few case studies also, where you will be able to understand and believe that geopolymer concrete is much better than conventional concrete in terms of properties, in terms of cost, in terms of environmental effects. So 100% waste material, it may be 100% fly ash you can use 100% rice husk ash or GGBS as a pozzolanic material, which is termed as aluminosilicate material. So what we are doing, the concern which we have discussed in the previous slide, that means utilization of waste material, that was one of the concern that is getting addressed here in case of geopolymerization. Second concern was the release of carbon dioxide. So no carbon dioxide released here because we are not using any conventional cement, that means Portland pozzolana cement or ordinary Portland cement water. So that means issues and concerns which we have raised or which were raised by World Earth Summit, that means use of industrial waste, agriculture waste, as well as emission of carbon dioxide can sufficiently be curtailed by using geopolymer based material in comparison to conventional cement based material. So a tagline we can say that geopolymer are green, environmental friendly material. Now let us go through this diagram where we are going to discuss geopolymer concrete manufacturing process. So at the first of all, the basic material is aluminosilicate material. It may be fly ash, it may be metapoline, GGBS, rice husk ash, whatever. You can take any one of them or you can take them in combination also. And after that, you add all these into sand and aggregate. So instead of cement, we are using these, any one or a combination of the material. And after that, here we are creating alkaline solution, sodium hydroxide and sodium silicate. We are adding them as per requirement, as per the mixed design methodology. And after that, when you add them, you will get a solution that is alkaline solution. And that alkaline solution is added with the dry material. That means sand aggregate as well as fly ash. So after that, you are getting geopolymer based material. It may be geopolymer mortar, geopolymer paste, or geopolymer concrete. So these are the few photographs which we have taken during development of geopolymer concrete in our own laboratory in University, where Parul Bansal was also faculty previously. So first of all, dry mixing of the aggregate sand and fly ash in a pan mixture. And after that, we are adding the alkaline solution, and that is wet mixing. And after that, the material obtained from this mixture is poured into the cubes for testing purpose, and then finishing of the geopolymer. After that, we can take it in two ways. Either you can wrap it in polythene bags and put in heat curing oven. So electric oven you can place so that heat curing can be done. And these plastic paper are wrapped so that whatever the water available in the mixer, that should not get evaporate. So polymerization should take place efficiently. And if you are not concerned about the early strength, then you can you need not to take the heat curing. You can just place them in open to sky as in conventional concrete, and later on it will get sufficient strength as per the mixed design requirement. Now you can see the actual photograph where we have tested in a very left side photograph. Compression testing machine is there, and we have tested the geopolymer concrete cube. Compressive strength test was done, then split tensile, and then water permeability test were also performed. And interesting factor is that we have developed the geopolymer concrete with a varying compressive strength of 44 to 82 MPa. So that means 82 MPa strength concrete we have developed in our own laboratory. So no need to worry, no need to get any perception, wrong perception. So you can believe in the geopolymer concrete that it is much better as compared to conventional concrete. Now, major concern about the geopolymer concrete based on the previous research. So we have discussed research since last 30 years. So major concern, even you people can ask me a question that why geopolymer is not currently utilized in major construction industry, or you are just, whenever you visit any site, you find cement-based concrete only, not geopolymer, because some few perceptions are still linked with this production of geopolymer. That process of geopolymerization is slow, as we have discussed, at lower temperature. That means ambient temperature. And you can increase the process of geopolymerization with heat curing or steam curing. So earlier, this was one of the drawbacks. That means you can't use this type of concrete, which is having slow setting process and slow strength gain, not less strength gain, better to say slow strength gain. So in conventional type of building, residential buildings, we are not accepting it. That means it will gain the strength. So earlier strength development as compared to OPC based concrete was quite lesser. So people were not getting confident on geopolymer concrete. But it can be better utilized in precast industry, because in precast industry, you have enough funds and you can develop a specialized heat curing system. And by heat curing, you can accelerate the geopolymerization as well as the early strength, as well as you can, that means you can fast the setting process. Lesser acceptability in general construction, as already discussed, due to ambient curing temperature, because it's a slow setting process. But need not to worry, in the last few years, last few decades, researchers have significantly addressed these demerits by doing the research with the use of some nanomaterial, by including nanomaterial, And by that we can increase their acceptability at ambient temperature. That means with the use of, with the addition of, inclusion of nanomaterial, we can develop, we can fasten the setting process as well as strength gaining process even at ambient curing temperature also. Now, this is the finding of even one of our research paper on the title was the effect of nanomaterial on the property of geopolymer derived. So it was a review article published in Construction and Building Material Journal. And here we have discussed, we have explored the research globally within last 12 to 15 years. So geopolymer products were taken into consideration. So from this first graph, graph A, you can see we have gone through the research papers where study was conducted on paste, geopolymer mortar, as well as geopolymer concrete. So three type of material were taken under investigation. And you will find that the interesting part is major research was contributed on geopolymer paste. Only 16% research was on concrete. So from this slide may be very useful for PG students as well as PhD scholars to work on geopolymer concrete, and we will be finding the gap in the study. That means there is gap was clearly visible that you can continue your study, you can work on geopolymer concrete as your PhD thesis on concrete also. Now, what are the various aluminum silicate sources? That means precursors. So you can see in graph number 2, B graph number. So slag was used by many researchers, fly ash was used, metapoline was used, volcanic ash, rice husk ash, and the blending of any one or two. So from this graph, you can check that most of the study, even 50% of the study was, research study was contributed with the help of fly ash. They were conducting developing geopolymer concrete or other material by using raw material fly ash. And other slag was nearly 16%, and metapoline, yes, they have studied, but rice husk ash was not much explored. So this is a gap in the study. You can work on rice husk ash as well as blended material. And what are the various nanomaterials they utilized? Graph C indicate nano silica they have used, nano alumina they have used, nano titanium dioxide, carbon nanotube, as well as nano clay. And here we have concluded that nearly 47% of the research in the last 12 to 15 years, they have used nano silica to improve the properties of geopolymer based material at ambient temperature as well as higher temperature. So nano silica and nearly 23% nano alumina they have used, 9% approximate nano titanium dioxide, and nearly 14% for CNT, carbon nanotube, and meager amount of study was on nanoclay. Now, what was their observation? What was their conclusions? That means strength properties which they have discussed. So you can see in graph number D, number of studies versus the type of study, that which property they explored. So very few studies are available on exploring the tensile strength of geopolymer concrete. Most of the study were contributing towards the compressive strength as well as microstructure. So from this research paper, that is a review article, you can find out the gap in the study. And even in BTech final year project or PG thesis as well as PhD thesis, you can work on those areas where still gap is there, research gap is there. Now, this also same paper, the compressive strength range and various researchers. So you can find that if we talk about this graph, these graphs, so this red color graph is for nano alumina, then nano silica, blue color, etc., etc. So interesting part is When you explore this graph, try to understand or evaluate this graph, you will find that strength range, compressive strength range uh, in the research globally, it ranges from nearly 10 MPa to 90 MPa. So that means whatever the wrong perception that geopolymer will not gain compressive strength, that is clearly visible that you can develop the compressive strength even up to 90 MPa. Now, one of the case study that is also research, geopolymer concrete paving blocks made with recycled asphalt pavement aggregate. That is the recycled aggregate basically. So asphalt pavement, when it is broken down into pieces and aggregate are prepared, so recycled aggregate towards sustainable urban mobility development. So this research is from India, and this research I have mentioned also the paper. So geopolymer concrete paving block made with recycled asphalt pavement aggregate towards sustainable urban mobility development. Now there I have taken two graphs. One is compressive strength geopolymer paver block at 7 and 20 days. So you can find compressive strength we have achieved from 0 to nearly 75 MPa. So 7 days strength as well as 20 days strength. Now the limits, there's a dotted line as well as hard line there, two lines are mentioned as per the guidelines, as per the restrictions of IS 15658, which is limiting for non-traffic type of payment as well as light type of payment. So research clearly indicates that with the help of even a recycled aggregate, you can develop geopolymer concrete with sufficient or quite greater strength than which is minimum is required for as per the IS code on provision. And the right side graph is the effect of these recycled aggregate content on water absorption of geopolymer paver block. So in the first graph, we are talking about the strength development with the use of a recycled waste material, that means recycled aggregates. So waste aggregate you can use. So water absorption graph is clearly indicate that it is quite below the limit prescribed by IS 15658. So this is the limit, up to 6% water absorption is allowed. And you from this graph, it is clearly visible that the water absorption has been decreased from nearly 5 to 3%. So by showing this slide, from this slide or from this research, we can understand that we can develop geopolymer concrete and we can utilize it in paving material also, paving blocks. Moreover, you are using waste material fly ash as well as other waste material. In the other sense, you can say that is pavement material, and you can take them as aggregate, you can use them aggregate. Now, this another case study that I have taken from technical report of 2019 and Wyndham Street of City of Sydney. And what they have done, they have developed geopolymer concrete mix with 75% slag. So slag is another waste material. So people are using even 75% of slag and 25% of fly ash. So both the material are waste material and even 100% replacement. So this is blended type of geopolymer concrete. So these photographs clearly indicate that earlier there was wet pavement and that pavement is already in deterioration stage. And after that, the pavement was demolished, then level the base surface and placing of the mesh reinforcement. Vibration strain gauges were deployed there to understand the vibration. Then the resistance strain gauges. Now, what strength they have achieved? They have achieved 20 MPa of strength at the time of opening of roadways. And the 28-day strength was reached 40 MPa. That is quite high. And this information we have taken from one of the study, that is installation of geopolymer concrete pavement at this study and Sydney. So first study we have taken, case study taken from India, now it is now Sydney. Now it is in continuation, you can see the strength gained was 20 MPa when the street was open to traffic, and later on 40 MPa strength was the ultimate strength. So pouring, leveling. Now you can see here, the surface was completed at 4 p.m. on Sunday. That means Sunday evening surface was completed and it was available for the traffic on Monday. So you can easily understand that how easily you can customize the properties of geopolymer based material also by using 100% waste material. Now these are some of the studies of geopolymer on pavement works. So this table indicates that we can use natural aggregate, we can use polyethylene type of plastic, as well as construction demolition waste also we can use. 100% we can use recycled concrete aggregate. We can use metapoline and slag. These are waste material. Fly ash and slag you can use. Fly ash, again fly ash is high calcium fly ash can be used and useful in pavement repair. In repair work you can use. Road bases, new construction you can use pavement construction as well as pavement based material. So this slide, this table indicates that we can use different type of waste material, polyolonic material in the development of geopolymer concrete, and we can use various other type of waste material, just like aggregate. You can replace natural aggregate with recycled type of aggregate. Moreover, you can utilize it in every aspect of pavement, whether it is a new pavement or whether it is repairing of the pavement. So what are the benefits of geopolymer concrete? It is cold setting technology. We have already discussed that only endothermic reaction is there, not exothermic. Cement free, you can take the nomenclature, you can say that it is a green concrete. It is suitable for concrete roads of strength requirement between 10 to 50 MPa. So what are the major benefits? These are mechanical property, chemical resistance, fire resistance, and thermal insulation. Short time to gain maximum strength, good abrasion resistance, even a reduction in cost of concrete from 10 to 20%, which is the major concern many times. Everybody asks that whether it is costly or cost effective. Yes, it is cost effective. Nearly 80% reduction in carbon dioxide emission. So it is environmental friendly. Wide span of application we have discussed so far. Increased utilization of industrial waste. Now, this slide also point out all the information that geopolymer concrete reduces global warming, reuse of industrial waste, eco-friendly, sustainability is also there, and the reduction in carbon dioxide emission. Now, few photographs from throughout the globe we have taken. So this photograph, GPC application in structures. So you can see this huge structure, 3 suspended floor building, and it is constructed with the help of geopolymer concrete. And here, geopolymer concrete was used as a structural concrete in Australia. And in another huge structure, geopolymer precast floor panel, sustainable concrete for Australia Global Change Institute. So this huge structure is made up of geopolymer concrete itself. Another application, there is a precast geopolymer cement concrete house. So even a residential, commercial, everywhere we are going to use geopolymer concrete. In future, we will find various buildings in India also. Now, repair material. Earlier, we have discussed the geopolymer concrete as a repair material in pavement. Now, you can see here, this is one of the geo-spray type of geopolymer. That means it is a spray material. It can be applied as a liner, and it helps in creating a new structural pipe within the hole. So somewhere where cement concrete pipes are there, and the repair is very difficult. So you can use these type of commercial available product based on geopolymer. It requires no digging, and that means you can eliminate the traffic daily. So these are the some of the references, some of our own papers which are published in construction and building material as well as ESPR journal. Now I can take your queries, your questions.
If anyone having questions, you can write at Facebook.
You can ask me your question, I will respond to your queries. So Parul, is there any question which I need to answer?
So till now, I haven't got any question.
Okay, so can I conclude?
Yes, sir, you can.
Okay.